In the previous video, we saw how to define a basic Python class and create an instance of it. Now let's see how to create instance methods and attributes for our class. So to do that, let's go ahead and open up instance_start.py. And you can see that it's pretty much where we left off from the previous video. So here's my book class and the init function, and where we create a couple of book objects. So let's start by filling out the init method a little bit more, since books tend to have more information about them than just their title. So let's go ahead and add arguments for author and page count and price. And then I can go ahead and add these. So I'll have self.author, and we'll add pages, and then we'll add price. All right. Now, each one of these attributes is called an instance attribute because the value that it holds is unique to each instance of the object that it's declared on. And the same goes for instance methods. So far, we only have one, which is this init function right here, but we can add more. So let's add a method to return the price of the book. And again, remember that every instance method takes an object as the first parameter. So I'll name my function getPrice, and the object is the only parameter in this case, and I'll go ahead and return self.price. All right, so now we can update the code where we create these books. So let's add the authors. And War and Peace was written by Leo Tolstoy, and it's a big book. It's got 1,225 pages, and we'll set that to be $39.95. Catcher in the Rye was written by J.D. Salinger, and that's a little bit smaller. It's got 234 pages, and we'll set that to be $29.95. All right. So now let's try making a call to the getPrice method. So I'll print b1.getPrice. All right. Let's go ahead and run the code we have, and I'll just run it right here in Visual Studio Code. And you can see right there is the price, right? $39.95. Okay, so let's go back to the code. Now, we're not limited to creating instance attributes just within the init function. We can do it elsewhere in the object as well. So let's add another function that specifies a discount for a book that's on sale. And I'll call that function setDiscount, and that will take the object and the discount amount, and we'll set self_discount equal to the amount. Now, notice how I have an underscore in front of the attribute name. The reason for this is to give other developers who use this class a hint that this attribute is considered internal to the class and should not be accessed from outside the class's logic. Other languages like Java or C# have a way of declaring attributes that are only intended to be used within the logic of the class where they're defined. But Python doesn't have a formal way of enforcing this. The underscore in the name basically tells other programmers, hey, this attribute can't be relied on to stay this name, so don't use it in your code. So now that we've defined the attribute, we can use it elsewhere in the class. Let's modify the getPrice function to use the discount if it's defined. Now, since discount was not defined during the init function, we can't rely on it being present because setDiscount might not have been called yet. So we need to test for it by using the hasAttribute function. So I'll call if hasAttribute, and I'm going to test my object to see if the discount attribute is present. So if it's there, I'm going to return self.price minus self.price times self.discount. Otherwise, just return self.price. All right, so let's try that function out. So we'll go ahead and print book 2's price, and then we'll set the discount to be 0.25%, and then we'll try printing the price again. All right, let's go ahead and run that. Okay, so here's the price of book 1. Here's the price of book 2 before the discount. And then here's the price of book 2 after the discount. All right, so one last thing I want to demonstrate. Let's go back to the code. Now, as I mentioned earlier, the underscore is used to indicate that an attribute or a method for that matter, is intended to only be used by the class. Now, if you use a double underscore as the start of an attribute or method name, then the Python interpreter will change the name of that attribute or method so that other classes will get an error if they try to access it. So let's look at that. Here in the init function, I'm going to add an attribute named secret, and I'm going to name it underscore underscore secret. And I'll give it a value that just says this is a secret attribute. All right, so now let's try to access that attribute. I'm going to print b2 dot underscore underscore secret. All right. So let's go ahead and run this code. Let's go ahead and comment these out first. So let's run that. And you can see that I'm getting an error because that property can't be seen outside the class. You can see it says attribute error and that the book object has no attribute double underscore secret. However, this is not a perfect mechanism. So the way that Python does this is by prefixing the name of the attribute with the class name. This is called name mangling. The reason for this feature is to prevent subclasses, which we'll learn about later, from inadvertently overriding the attribute, but other classes can subvert this simply by using the class name. So if I go back to the code and just simply put underscore book in front of this and then save it, I'm going to run this again. All right, well, there's the printout, right? It says now this is a secret attribute. You can see now that I can access the property. So it's not a perfect solution, but you can use this approach to make sure that subclasses don't use the same name for an attribute that you've already used. Now, in some cases, that's exactly what you want. You do want subclasses to override things sometimes. But if you need to make sure that they don't, then the double underscore can prevent that.